Welcome back, everyone, to day 3 of the ActivityBot 360 Educator Workshop. As usual, here is a link to the slideshow along with various types of links so you can get to it later via a mobile device or typing in the link. It will also be in the details of the Zoom or of the YouTube recording. Chat. Paste. Okay, so I redid the agenda a little bit. It now, the previous days now reflect what we did cover. And today I'm going to talk about our upcoming workshops and also the slide and video locations moving forward for this workshop. We have one place where we keep the video links and the slideshow link along with a description of the workshop. Then we'll talk about project and applications. I'm going to review all the projects, all the applications and activities that are done in the base kit, then talk a little bit about some of the extras. Then we'll talk about purchasing options. We'll look at logging into learn.parallax.com to access the educator resources. Then we'll take a look at attendee demos. And along with that, we may need to do some app troubleshooting. And last but not least, wrap up in Q&A. If anybody has any questions along the way, please make sure to just unmute yourself and say, hey, Andy, I have a question, or chat Ari and or Stephanie or just everybody, so that everybody's better, because that way everybody will get to see the answer, both the question and the answer, which may be helpful for others. So for upcoming workshops, let's take a look at that page. It's the Parallax events page. And we currently have 2 workshops coming up. One is October 24, 6, and 8. It's a electricity and electronics with the microbit. Very cool workshop that has a virtual workbench with a web-based voltmeter and oscilloscope to in addition to simply writing programs to make your circuits do cool stuff. You can actually use the microbit to take measurements using the probes shown here. See if we can get a better look at that. So these probes are actually used in this case to measure continuity. And so this is a really cool workshop. I like it a lot. I like the system a lot and highly recommend it. Stephanie, can you talk a little bit about when, because we're actually just, we took the page down, but we wanted to let anybody in who's in this workshop that thinks that they could benefit from using this system to teach electronics and might want to try it.
I'm wrapping up signups right now. So if anybody's interested, the link to sign up is still on this page just for a little while longer.
Oh, okay. So the page that Stephanie is talking about also.
Apply here link is at the bottom. And that's the information about the course. And it's just an application shorter than the one that you did for the class you're in now, if you're interested.
Yes.
So if you already have signed up.
And the place to find it, if you're not jumping into the chat, did you paste it into the chat, Stephanie?
Mm-hmm.
Okay. So if you weren't looking in the chat, you could go to community events. And then here is the electronics with Python and the microbit. And you can go to view event and apply here. How long is that going to go? Say maybe till the end of the day, Stephanie?
Yes, just another couple hours, and I'll be taking it down.
All righty. Now, another thing about this area, this community events, is that not only can you see the upcoming events, but you can also see past events. So for example, if you wanted to, if you haven't taken the Cyberbot course, you could potentially purchase a Cyberbot. And then if you go to view event for this Cyberbot course, and there's a whole lot of, we keep all our workshops on here, as well as certain Propeller Live forum events. And so here is the workshop with all 3 videos, and then its slideshow at the bottom, just like it's going to be for the for this current, soon to be previous event. Whoa, where'd it go? Education, educator workshops. Here we are. So this one that we're doing right now will end up in the past events section. And then these are the upcoming events. We're also doing cybersecurity at the NICE K-12 conference in St. Louis, Missouri on December 5th and 6th. So anybody who's there, please come and pay us a visit and sign up for our workshop. It's a lot, it'll be a lot of fun. Okay, so that also covers the workshop archive. So next I want to talk about, and now be ready, because later in the, well, actually we're going to do some programs early on here, and then I'm going to talk about the educational resource. And just to warn you, we will be after that running our demos and talking about them. So be ready to run your demo if you are so inclined to share it with all of us. Okay, so first off, this is a review of what's in the kit in the sequential order that students normally go through it. So the first up is getting started with Blockly Prop Solo. You did this for homework. And I just want to point out that there's software installation, first program, and how to use the buttons to save projects. And all of our chapters basically have the contents along the left. And you can also use the previous and next page buttons at the bottom. Then we went through learning how to program, and this is where a lot of computer science curricular checkboxes get checked in terms of, you know, conditionals. Those would be making decisions, which should be blue. I'll get back to that later. Yeah, so, oh, I see. I made it not blue because I assigned it as, or I was planning on using a circuit chapter or a circuit activity. Anyway, this should be blue. I'll go ahead and change that later. And also repetitions, conditionals, and then basically calculations, communications, all those basic computer sciencey things are initially addressed here in a terminal only kind of way, or a blinking lights only kind of way. And after that, there's a little side trip into multi-core programming. And because this is the multi-core propeller microcontroller that we've been working with, I would be remiss, I think, into not guiding you through an example. I'll show you what is in the multi-core Blockly programming. It explains, well, it starts by explaining the difference between multi-core and single core, which I talked about on the first day. And so there is a lesson on functions. Functions are groups of code inside a function block. And you'll notice the function's name here is print age. And so whenever the main loop really starts up here, clears the screen, asks you how old you are, then you type a number and it stores it in your age. And then it calls two functions, print age and old age. And I didn't try this, so I'm not exactly sure what old age is doing here. You will be 100 and countdown. So it calculates countdown somewhere. Ah, okay. So basically it calls print age, jumps down to here, says how old you are. And then it also calculates the difference between your age and 100. Now, old age then tells you how many years that is. And that kind of underscores that this variable countdown is a global variable, and all variables in Blockly prop are global, meaning that even if they're inside a function block, anywhere else in the program, you can still access them. Many programming languages will not let you do that. They'll only, if it's inside a counting loop, maybe that variable will only be available for the use of that counting loop. So more discussion about multi-core. And then the hands-on part where you write a program. And this program, essentially, the main program here uses, it sets up a timekeeping function. So this counts seconds in a separate core. And what it does is it does so very precisely. Meanwhile, this other core just basically displays the time. And you can essentially press a key and find out when the updated time is. And this is all independently running in one processor while the timekeeping is running in another processor. So I have a slightly different lesson for you today on multi-core. And so I'd like to try that. And we're not going to nuke any of your programs that are in the ActivityBot. So that's upside down. Well, I'll just make it like so. Okay. So what I would like to do is have you all, first of all, set up your Zoom meeting so that you can see it at the same time that you can see Blockly prop to write some code. So let me know when you're all ready for that. So you'll need your Blockly prop launcher running. You'll need to be at solo.parallax.com. And then you'll need to have your COM port selected if it wasn't automatic. And so go ahead and do that. And when you're ready, please give me a thumbs up. And remember, the view options are in the upper right of your Zoom window if it's taking up your entire screen. Excellent. Thank you, Marcel. Anybody else? Looking good, Stan. Thank you. Thank you, Sheila. How about you, Chad? Are you up and running?
Ready to go.
Ah, excellent. And Nielka. Ah, thank you, Sylvie. Okay, so unmute yourself and shout out if you're not ready to continue.
I apologize. I got sidetracked because I was very intently trying to get into the workshop at the end of October. So
Oh,
I'm sorry.
oh, that's fine. So what you want to do is run Blockly prop launcher.
I have that.
Okay, then go to solo.parallax.com. And then also try to arrange your screen so that you can see what I'm doing on my screen, as well as your own Blockly prop solo.parallax.com browser, because we're going to be copying each other's work here.
Oh, okay. I got them both up.
Excellent. All right. And then anybody else, please do feel free to ask me to slow down. So the first thing I want to do, we're going to start by just simply blinking a light. And to do that, we need 2 blocks. One is pause. That's you'll want to click Control and select pause. So Control and pause. And the other one is in pin states. It's pin states, and then the topmost block, make pin. So pin states, make pin. Connect your pause and make pin together. And then set the pin argument in make pin to 26. There's a little scroll bar that you can use to go up and down. So when you click the drop down, you won't see 26, but you can scroll down and then select 26. And now we have make pin 26 high. And after that, you can right click each block and select duplicate. And then connect them all together like so. And then the second make pin 26, if we're going to blink the light on and off, we want the second one to be low. And then we can speed up the blink rate by making the pause between ons and offs a little shorter, like 750. This program will currently turn the light on and then turn the light off and then end. So what we can do is go to Control and grab the third block down. It's called Repeat Forever. And then clip it over. See how I'm approaching it at a 45-degree angle towards the upper left corner. And then it gives me a shaded area saying it's going to gobble up that whole block of code right there. And once it does that, you can let go and it'll just clip right on. Another way you can do it is just to simply place it and then drag your routine here and drop it into the repeat forever block. Either one of those is fine. Okay, I'm going to wait a second for you guys to catch up. And important, hold everything. we don't want to erase your program if you have some homework that's ready to demo later. So for this, we're always going to use the run once, load code to RAM. So that's the downward arrow without the horizontal line below it. Another way to think about it is it's the downward arrow right next to the check mark. So we're only going to do run once on these guys so that we don't nuke your application code for your robot. Oh no, Marcel, too late, huh? You did save it somewhere, right? No?
Well, that's the lesson.
Yeah. In the school of hard knocks. I hear they offer university degrees in that. Okay, so go ahead and hit the run once. And then when you go to your robot, we want to see the P26 light blinking slowly. Is that rendering okay over Zoom? Excellent. Okay, now bear in mind you could reduce the number 750 to make it blink faster. Now that we have this, I'm going to do my own little introduction to functions. So next thing to do is place a function block that is in the menu named functions, which is the 6th one down from the top. So click function and place the function block. We normally place the function blocks below or to the right of the main code, but it actually does not matter. You could place it above the main code. And then for a name, let's give it the name Blink P26. Okay, so the next thing I want you to do is take this code that was in the repeat forever block, our blinking code, and pull it out of the repeat forever block and put it in the function block. Then go back to functions, and there'll be a second block. There was only one block there previously, but now you'll see a run function blink P26 block. Take that and place it in repeat forever. And if everything is right and okay, this program won't change. So as in the behavior of this program won't change. So I'm going to go ahead and download it, hoping that the extra air conditioning won't cause my computer to have little hiccups. However, I am going to mute the video of me while we're doing.
Andy, we just lost your audio.
Oh, you know what? Yeah, thank you. I muted my audio. Okay, I need to turn off my video. Stop video. Okay, so that hopefully will also take some load off my computer. All right, has everybody still got a blinking light with this modified program? Go ahead and hit the downward green arrow. Thumbs up, excellent. And that's as it should be. However, with code running in another core, it's better to have it, it's crucial actually to have it running inside a loop. So here's a funny thing that's going to cause some trouble as an initial step. What we're going to do is we're going to pull that run function out of the repeat forever. Then we're going to pull the blink code out of the function. Put the repeat forever in the function. And then put the blink code back in the repeat forever. And when you're done, we just want one block saying run function blink P26, and then a function with a repeat loop inside it. And inside that repeat loop, we want to have the 4 light on off blocks. And this should still work. But I'm going to add a twist. And that twist is to take the make pin P26 high, right click it and select duplicate. Put that underneath run function blink 26, and only in the one that's underneath run function blink P26, we're going to change that make pin block to turn P27 on. Okay, so give me some thumbs up when you make it to good job, Marcel, when you've got it. Excellent. Thank you, Chad. Thank you, Marlon. Thank you, David. Thank you, Sheila. Okay, let me know if you need more time to catch up. Otherwise, we're going to keep going. Now, what's supposed to happen here, or what one might expect to happen, is that the light would start blinking and then the P27 light goes on. However, because of the fact that this is an infinite loop, this code can no longer return from this function. So it would normally go to the function, do what's in it, come back, and then do what's next. But again, because this is repeating forever, the one core executing this can no longer come back to make P27 high. And if we run that, we'll see that we still have just a blinking P26. All right, so now it's time to make this function execute in a separate core, so that we'll have one core that will be allowed to move on to P27, and then another core that's constantly doing stuff to P26. So pull apart, make pin P27 high, pull it away from run function blink 26. Then go to control, and all the way at the bottom of control, almost the bottom, is the new processor function. So grab the new processor function and actually clip it onto the run function blink 26, or put run function blink 26 into the new processor function, either way. And then clip make P27 high down below. And run it. And this time we want to see that the P27 light immediately to the right of the P26 light we want to see that P27 light come on. Okay, so now I'm ready to run it myself. And it did what the program said to. Everybody with me still? Thumbs up. Excellent. And nods. Oh, great. Okay, awesome. All right. So now what the heck? Let us, instead of making P27 high here, why don't we just run another core? So to do that, right click, we're going to duplicate this function and update some of its values, and then duplicate the new processor and have it also update and update which function gets run. So step one is to right click the function and select duplicate. And interestingly, Blockly cleverly auto increments the numeric part of the function name. So it already reads blink 27, but we're not doing anything with pin 27 in the make pin blocks. So now the other thing you'll need to do is change the make pins to 27. And then the other thing would be nice, would be to change the pause so that you can see the lights blinking at different rates. So let's try 650. How about 600? I don't know which is going to be better. We can experiment with that. Next up, we can discard this make pin 27 high block. So grab the one that was up top below the new processor function and just toss it in the trash. And after that, duplicate the new processor block, get rid of the run function blink P26, and go back to functions and grab run function blink P27. And when we run that, you will see P26 and P27 each blinking at different rates, because each one has a different function running in a different processor to make it blink at a different rate. So sometimes the lights will come on at the same time, and then other times one will be on and the other will be off, and it's going to continuously cycle through this in phase, out of phase, on, off, because of the fact that they're blinking at different rates. Okay, how are we doing? Good job. Excellent. I've got 4, 5, 6. Oh no, that was 6. All right. Now, one more interesting thing you can do, you'll need to move your functions. You can actually put them like this. They don't really, it doesn't matter how your functions are ordered. You can put them any old spot you want. But what we need is we need more room. Well, we need more room before our main code right here. And by the way, this is running in processor 0, this main code. And right now, all processor 0 is doing is launching blink P26 into processor 1 and launching blink P27 into processor 2. And it always does this on a next available basis. So let's try pausing for 6,000 seconds. So go to Control and add pause. And okay, hold on. I need to remember what to do. Oh yeah. We need, in order to control the blink rate of these guys from up here, we want to be able to control the blink rates of blink 26 and blink 27 from our main thread here. And what we're going to need for that are variables. We'll need global variables where the processor running this code can go and write new values to the variables, and then the processors running these 2 bits of code can see that and adjust accordingly. So to do that, we need to go to variables, and we're going to add 2 new variables. We'll call one time 26, time P26. So that's one new variable, and then hit the new variable button again. That's variables, new variable, and then time P27. Hit OK. Now, then the first thing to do, or once you have time P26 and time P27, go ahead and grab from variables the time P26 and the time P27. And notice that I put them over the functions. That's just temporary. I just want everybody to grab time P26 and time P27. Okay, how's everybody doing so far? Good. Nod, yes, excellent, thank you. 1 thumb up, good. 2 thumbs up, 3 thumbs up, 4 thumbs up, aha. Okay, now I think you guys are with me. Good. Now, we need to remove these constant, thank you, Matt. We need to remove these, and sorry if I missed anybody. We need to remove these fixed times from our pauses down here. So you can just go ahead and click them and hit the delete key. Actually, well, I guess I should have said to save one, but we'll go back and get it later. Okay, so now we need 2 copies of each of these times. So you can right click time P26 and select duplicate. And then right click time P27 and select duplicate and put them where you just deleted those constant pause values. So this program is not quite ready yet, believe it or not, because those variables automatically initialize to pauses of 0. So we need to give them some kind of time that'll actually work before launching these processors. So back in variables, I want you to grab a couple of those. It'll probably say time P27, whatever it says. We want the variable that has the input, the socket that you plug a puzzle piece into. And we want a couple of those that we'll put above the new processor functions. And once you've got those, make sure that one is time P26, the other is time P27. And then we can go to values. That's the third menu item. And grab a 0, change it to 750, and then duplicate it by right-clicking, plug the duplicate into P27, and then maybe change that to 650. So that'll put us back where we were. And please give me a nod or a thumbs up as soon as you've got this ready. Thank you, Stan. Thank you, David. Thank you, Sheila. Thank you, Chad. Thank you, Nielka. All right. And then again, if you're behind, just give me a shout so you can catch up. Okay, so one last thing we want to do here is have our main processor maybe do a whole lot of nothing for 6 seconds. So we're going to put, if you don't already have it, go to Control and grab a pause and place that pause below the new processor function. Then right click and duplicate these two time P26 and P27. And we are just about ready now. So this is actually having processors, separate processors, communicate through global variables. Oh, wait, we need to see a change. So now that I've placed the, now that I've set these values down below. So we set the values that control the blink rates in both of these. We set those, and then we started the two functions and new processors. Then processor 0 is going to wait around for 6 seconds. And to see that this is working, to see that variables can indeed control the behavior of other processors, we need to do something with this. So we might want to like maybe double the blink rate. So we could set this one to 375 and this one to 325. So the end result, it should be that this will start blinking slowly. It'll do that for 6 seconds, and then it'll double both blink rates, and you'll still be able to see them go into and out of phase with each other. Okay, so on mine, it's slowly blinking. And it just doubled its blink rate. I'll restart that so you can see it. Okay, slowly blinking. 2, 3, 4, up. Yes, I didn't count fast enough. So try running that a couple of times and verify that it blinks slowly and then doubles its rate. Now, this is a very slow motion, tangible, hands-on kind of thing, but you can do some pretty neat things with multiple cores, wave players that you might have 2 cores talking to an SD card, and a third that's taking that data and streaming it to a D to A converter that goes to headphones, for example. And that's just one of many examples. Another one is you might be using feedback 360 servos in a robot. That's all happening in another core, and variable sharing is occurring. So whenever you call the function drive_speed, or let's see, what's it called? Robot drive speed. This sets variables under the hood that then another processor picks up, and that processor is very busy reading signals from the yellow wires and sending signals to the white wires. Okay, so what do you guys think of that? Is that kind of interesting? Something you maybe haven't seen before or didn't really expect to be doing multi-core application development in Blockly on a Friday afternoon? Just don't tell your neighbors at the barbecue this weekend, because they'll be all, what'd you do this week? Oh, I did multi-core application development. They'll say, gee, that's nice.
We did get it. That was fun from Sylvie
Excellent. Thank you, Sylvie. I agree.
and from Sheila.
I actually really enjoy this particular thing. Now, I have one last thing for you to try, and it's not going to work for everybody because it's going to have the whole bandwidth, the whole processor bandwidth debug terminal thing. Give me just a second. Going to go to my Google Drive and paste you in a link. Last modified. Okay, so I'll give you two things. The first is the whole folder. No, I'll just email you the whole folder because, well, so you had an email of the whole folder yesterday. I would recommend refreshing that because I added some more code examples today. But what I am going to do is step 7. There were 6 previous steps that we all did together. And I'm going to get the link for step 7, copy link, done, and paste that in the chat to everyone. Paste. Okay, and so now that you have, when you follow that link, it's going to give you this, hopefully now familiar download, and you'll go ahead and download it. And then after you've downloaded it, go to Blockly and hit, or let's save this first. So let's save this as, you know, Blink. Just a second, I need to remind myself what I named it. Blink Lights Multi-Core Variables, Step 6. Blink Lights Multi-Core Variables. Multi-Core Variables, Step 6. Save. Okay, so save a copy of that. Although, if you go and just get the code folder again, you will see all 7 steps. And then do open, choose file. And downloads. So there's step 7 in my downloads. Double click, select open, and here we are. I'll go ahead and rearrange this just a bit. Okay, so this one, when you run it, it's going to ask you to enter the rate for P26 and P27 after setting it to the initial 750 and 650 rates. So download that. I can hear my CPU fan speeding up. So hopefully it's not quite burdened enough yet to freeze up on the, nope, it's not. Good. All right, so here we are, enter P26 rate. So we'll do this one nice and slow. We'll make it 1,000. And why is it not offering to end to, Well, that just let the air out of my sails. Enter P27 rate. So I'm even having some of this Zoom bandwidth problem. Okay, and I'm gonna do this one 10 times as fast. So I'll just enter 100 for that. And so P26 is blinking very slowly, but as soon as I enter 100, notice that P27, it may be just solidly on for you guys. I can see it flashing. Does it look solidly on from the Zoom standpoint, or is it kind of flashing? I'll change it to 500 just to make it twice as fast. Oh, wait, 500 and 1,000. Okay, so P27 is blinking slowly at 1,000. I'm going to wait for the next message to come up. I'm sorry, P26 is blinking at 1,000. So we'll make P27 blink at 477. Now we can see that P27 is blinking faster, and it is in fact blinking a little more than twice as fast as P26. How'd that go? Still working on it? Okay. Good job. One thumbs up, 2 thumbs up, 3 thumbs up, 4. Hey, Marcel, at 5. Nice. Hey, Marcel, are you having the same delay problems I am? 6 thumbs up. Okay. Be patient, though. Oh, thumbs up to that. Well, be patient. Then the next message will come up, and then you'll be able to set the speed. When we're not on Zoom, that's going to be very responsive. It's just a Zoom bandwidth thing. And by the way, the difficulties that you saw me having loading code into my propeller last time, we're also assuming that I just had too much going on. That's why I turned off one of my 2 cameras. I'm trying to keep either one or the other camera on at any given time. All right, so that is multi-core. And before the break, I'm going to try to give you a quick rundown on resources. Oh, let's see. So everybody got that going. I guess just a final remark about this is that this is really still just a modified version of the previous. We developed up to a certain point where we had the initial values, the 2 processors running, and then we just simply tested to pause and change the speed. And then in place of that pause and change the speed, what I did is I added this repeat forever loop that grabs 2, that gives a prompt, then grabs a number value, then gives another prompt and gets another number value. And of course, those number values are seen by these processors, because we're storing one of those number values in time P26 and the other in time P27. And so again, that is multi-core, and it can really take you to some amazing applications. It's very, very useful and very powerful. Make a beep, we did that. That was part of the ActivityBot 360 circuits, where you learned about circuits. Then we constructed our ActivityBot robot step by step. After that, we did navigation basics, and the first thing was a test. We manually turned both wheels and verified that the corresponding light blinked for the particular wheel that we were turning. Then we did a calibration. Now, this calibration is not required for the thing to function. If you have everything connected properly, it will go from a default calibration. But what the calibration does is it just measures the top speeds of both servos and then records that in some permanent EEPROM memory that is not needed for holding the program. We have a double EEPROM that's twice as large as the 32 kilobyte program space. So it's 64 64K EEPROM, I believe. Then we did driving distances, which is something where you tell it how many ticks. Driving speeds, which you can do ticks per second up to plus or minus 128 for 2 turns per second, since a wheel turn is 64 ticks or 64/64ths of a turn. We also did taking turns, where we made one wheel either go slower or in the opposite direction of the other. After that, what students do is navigation by touch. And I guess my question first is, did anybody do the whiskers application? Chad, you did. Now, do you have it wired up?
No, I tore it down this afternoon.
Oh, shucks. Okay, well, we'll just look at a video of that then. Oh, well, how did it go?
Well, no
Good.
problems.
Okay, good. And that's what we try to do, is make sure there's no problems, because, you know, in Navigate by Touch, as with all the others, we start with a video so that the students can see what to expect. And so the ActivityBot's about to come into the screen. Here we are. And so it has not yet touched the whiskers that are sticking out in front of it against the box. But as soon as it does, it's going to back up, turn, and I think go to the right. Boom, hit the box, backed up, turned, and went to the right to continue roaming. And just like the ultrasound that we did on Wednesday, what we start with is a build where it has very detailed instructions on how to build the circuit. We always include schematics so that students get used to that. We make sure that everybody can succeed with the wiring diagram, but we also have the schematics. Teachers who are concerned about students being able to work from schematics often challenge them to build it differently from what is shown in the wiring diagram. Now, after building, we don't want to just jump into the whole application. That's always the temptation, but instead, what we do, like we did with the ultrasound on Wednesday, is we test the circuit to make sure it's measuring properly. And so for the whiskers, we have this test where it displays in the terminal, and then further down the page, we have a test where it displays just using those P26 and P27 lights that we did the multi-core with. And we also introduce ideas like, you know, how does an electrical connection work? What voltage does it apply to the I/O pin of the microcontroller? And then what is the result of that voltage? And in the case of 3.3 volts, the microcontroller's check pin block returns 1. In the case of when the whisker is pressed, it applies 0 volts to the I/O pin, and the check pin block returns a 0. So this is a nice introduction into binary numbers and also how it works in the electrical and electronic world. After that, then we start, so that the main thing is that students really need to test their circuit and make sure that both whiskers are detecting both one at a time and both at a time. So we have some checklist instructions, and they go through and they read in the terminal and see that it's 1-1 when the whiskers are not pressed, and then each whisker, when pressed, should result in a corresponding 0. And they have to get that right before they move on. Otherwise, the next thing, which is a simple application where you press against a whisker and the robot backs up, it won't work necessarily. And but so we do some simple applications, and then we ratchet it up with a full-blown roaming application, which is what you saw the little video clip of. Okay, next up, we did the ultrasonic. That's in the order that the students do it. The next thing they do is ultrasonic. And the one thing I want to talk about here is just that we do introduce the speed of sound and time of flight. So that's an important sciencey subject that gets introduced here. Science, physics, and essentially speed of sound is on its own as a topic of interest. Very good for STEM classes. Okay, then we have light following. Light following follows the same pattern. And so again, when we're doing light following, we have the robot just cruising along. And as soon as the guy off screen turns on a flashlight and points it towards one of the two sensors, one of the two light sensors on top of the robot, it will measure a difference between those two sensors and follow the light. And there's a lot of good material here. We introduced transistors in the form of a photo transistor in this case, which conducts more electricity when more light strikes its light collecting surface, or less when less light strikes it. And so we set up 2 light sensing circuits that actually have storage devices called capacitors. And by charging up those capacitors and then letting them trickle their current through each of these phototransistors, we basically measure the time it takes for the current to reach a certain state, or for the voltage to reach a certain state as the current discharges through that, and P9 and P5 silently watch that. And this is similar to RC decay, but it's not identical because it doesn't have that exponential curvature. It's actually a linear kind of decay when you're using a transistor, because a transistor makes current, it gates the current at a certain rate to travel through it. And so, yes, we do a test program again. And we also talk about more science topics, in this case, the visible and infrared spectrum and ultraviolet. And also the wavelengths of those lights. And so that's a good little thing in addition. And by the way, I use the term QT, and I didn't just make that up. It was some research. So RC decay is the one that most people are familiar with, that has this kind of exponential decay when you use capacitors in a circuit like this. But when it's a linear decay, or basically just measuring more generically the transfer of electric charge, we call it QT, or charge transfer. So these are QT, or charge transfer measurements that you're taking here. Last but not least, in the main kit, we have infrared navigation. And I need to real quick go to my email because I forgot to download. I'll replay this. Okay, so the robot's coming along. And now it's a little bit different. He's coming up to the box, but instead of running into the box like with the whisker sensors, he was about 6 inches away and saw the box and turned in place and found a new direction to go. So that's a nice thing about navigation from infrared. And the other nice thing about navigation from infrared is because we have 2 infrared sensors on there, it can decide whether to turn left or right. And with ultrasound, you might want to scan to turn left or right, or use random, but this will automatically decide whether to turn left or right. And I am going into my email very quickly to grab, actually, it's 4:04. I should give us a break. So let's come back at 4:10. That would be 5:10 Mountain, 6:10 Central, 7:10 Eastern. And so that by the way does cover the before you go, that covers the main kit and its activities, although I need to talk a little bit more about infrared and the lessons in there. But those are the things that come in the ActivityBot kit. But there's also some extra add-ons that either come with the class pack or can be purchased separately to add certain other topics to the ActivityBot, which I'll talk about after break. We'll see you at 10 past. And I will be back too. Stephanie, are you still there?
Yes, and the
Okay.
recording's still going during the break.
Okay, yeah, so the recording's still going during the break. I'll be back in a few minutes. And I'm back with 30 seconds to spare. 15, pardon me. Now, I actually didn't let everyone go until 5:30, so we'll pick up at I think I'll let it go clear to 11. Well, that's gonna completely destroy my bandwidth usage. I tried to open a video and it's opening my VMware. Virtual machine. Shut down. Yeah, I've never been more sure. And let's see here. Quit VMware Fusion. Phew, that was close. Okay. Everybody back? Thanks for confirming. Let's see here. So I'm going to try to maybe play that video with something different. Okay. So here we have VideoLAN VLC, and now I'm on my way to my downloads. We have a video shared by David of his Whiskers robot. So he sent his robot into a corner, and it's trying to figure out how to get out, but it did eventually make its way out. So that was pretty resilient. And I see that David also has added the optional indicator red LED lights, which can be used to show both in testing and during navigation, which infrared detector sees the object. So very nice job, David. That looks really great. And I realized during break that I forgot to say something about navigate by visible light, which is so we start actually in visible light by just taking measurements, and these measurements, taking and displaying light measurements. And these measurements are going to be drastically different depending on the overall brightness of the room. So one person might see 10,000 here, another person might see 500, and then shining the bright light, that'll vary a little bit too. And go to another room, and these numbers, although relative to each other, they will still be, different. You'll still have a small number here and a bigger number here. From room to room, things change a lot. And that makes it very challenging because you can't just say, oh, if the light gets to 64, or if the light goes below 100, you cannot necessarily say that and have a successful light following robot. And so what we do is something from physics. We normalize the measurement. And a normalized measurement is simply taking all your quantities that make up the entire thing. And in this case, there's just two. So we call it normalized differential. We put all our measurements in the denominator and then divide them into the measurement of interest that's in the numerator. And so this is measurement normalizing, a thing that I remember doing a lot in physics. And then this becomes completely immune to the overall brightness of the room. It'll work in a dim room. It'll work in a bright room. The robot will always be able to recognize that there is a difference, and it'll turn toward the light wherever it is, because we're comparing, say, the right light to the total light. And so that's one of the secrets behind getting this to work, no matter what kind of light environment you're in. And then in the infrared, I also wanted to mention that there's a couple of things that I want to mention. One is that the infrared headlight shines ahead of itself, and if there's an obstacle in front, it bounces back and goes to the infrared receiver. This infrared headlight is actually the same one that you'll find in TV remotes, the old kind that you used to point at your television before they became radio and Bluetooth. And then this is what you would find in your old television that worked with that remote. Another thing is that we have two different shapes of clear thingies, those being infrared phototransistors and infrared LEDs. The infrared LED has a more dome-shaped top. In contrast, the phototransistor has a flatter top. And your students, some of them may make a mistake and use the wrong one. The other common mistake is to simply not pay attention to which pin is longer. That is called out. Like we're saying, hey, the shorter leads need to go into these two rows, and we want to see flat spots closer to the two pins that are by those shorter leads. And basically those are two separate indicators. So if you ever end up trimming the leads, the flat spot will still tell you which of these two pins was the formerly shorter lead. The collector, I believe. No, the emitter. Collector, base, emitter, current flow, which is another lesson in there. And then, so that brings us to the end of what's in the kit and the lessons that we have for you. Now, there are also some projects. These projects require additional hardware, and not all of it's really all that expensive. But these are optional projects. The TV remote, the line follower, and the rotating ping ultrasonic turret are included in the class pack and probably the most commonly used of the kits. But we also have some others for like following colored lines, for finding an infrared beacon, and then there's a really cool thing with the CMU cam for determining which object you want to pay attention to and which one you don't. We also have the C language has some additional activities that involve SD cards, keyboard control, and then some kind of cute joystick control. Again, CMU cam. There's the QtiBot and the polite ActivityBot. These two, the kitty cat bot will roam along, and if you get in its way, it'll meow for you to get out of its way. And if you do get out of its way, it'll purr and continue. And these sounds are recorded on an SD card as WAV files. And if you don't get out of the way, it'll hiss at you and then turn and go another direction, just like a cat might. So here is the example of the infrared remote control. Oh, I forgot to link this. Oh, there it is. Okay. And so, so there's a video clip that shows how to get set up. And there's some information along with the video clip. It shows how to make sure that your remote, your universal remote, is behaving like a Sony remote signal-wise. And then you can read buttons. And it talks actually about how this infrared light is flashed on and off at 38,000 times a second for it to be able to be seen by the TV receiver. that is sending signals to your ActivityBot. And it'll flash on and off for 2.4 milliseconds to tell you that it's the start of a message. 0.6 milliseconds is a binary 0, and 1.2 milliseconds is a binary 1. And so this is this gives us and students an introduction into communication protocols. Let's see if we have any good video clips on that page. I don't remember. Okay, so this is all how to. It's nice though. It's how to support on video, in addition to the written support, which comes on the next page. So basically what he's talking about in his video is also documented here with pictures and checklist instructions. The Qti Line Follower is pretty fun. And so here we have a full set of instructions for setting up the line follower and getting basic line following going. You can make some really challenging courses. The basic code example just follows an unbroken line. You can put breaks into the line. You can put intersections, all kinds of things to throw the students for a loop and challenge them to develop a hypothesis on what code would solve the problem, and then test it and decide after running several hypotheses and tests what's going to be the best for, say, a contest. And so that's the Qti Line Follower. Then we have the ping mounted on a turret. So down here, the ping is actually mounted on a standard servo that will point this ultrasonic rangefinder anywhere in a 180-degree range. And so the program actually sweeps the ping back and forth, and you can do ping-dar radar with it and have a nice little radar display. And you can also, so here's a close-up, here's the standard servo that the ping is mounted on. And so this little part right here will rotate to point the ping in various directions. And there's some fun stuff that you can do here. It's not showing a picture of the radar display, but you get a radar display out of this. And so you can see the bottle in a semicircular display in the debug, or in the serial terminal. And more fun stuff like the IR beacon, the color pal for colored line following, and then the really neat one is the Pixie Cam. And so here's the Pixie Cam, and this tutorial goes through getting everything all set up. And I think down in the speaker notes. Oh. Let's see. Here we go. No, I didn't put it in the speaker notes. I put it in this gripper page right here. Okay, so this is actually an example of the gripper plus the CMU cam. So you can use the gripper on its own, and you can also use the CMU cam on its own for recognizing colored blocks. But together it's pretty neat. So this will show initially the gripper and just the gripper's usage, and then near the end of this clip you'll get to see the gripper in conjunction with the CMU cam. That's Carnegie Mellon University, by the way. Okay, so here is the here we have the CMU cam, and so basically students would do the gripper on its own and the CMU cam on its own, and then do them in concert. And that's where this application comes in, where when he places the yellow block, it knows to look for that and actually pick it up and take it somewhere. So those are some pretty powerful add-ons. In addition, let's see, I forgot to add a slide with a link to it. I'll go ahead and put one in there. But if you go to www.parallax.com, oh, no, I'm sorry. It's just a little ways ahead. I'm going to skip ahead just a little bit. Okay, so here are the ActivityBot 360 products. I mentioned these on Monday.
I've already pasted a link into the chat for that.
Oh, that was quick. Thank you,
Well,
Stephanie.
Sylvia was ahead of you with a question about compatibility from some of the accessories she saw we used with the CyberBot. So,
Oh, yeah. So yeah, the CyberBot robot has a very similar class pack. The Qti Line Follower, the ping on the turret, and the TV remote are kind of a mainstay for all the class packs. And so the difference is that with this one, since it already has the ping in the kit, whereas the CyberBot does not, this has just the turret part, the servo on the turret part, whereas the CyberBot also has the ping added to its class pack. And so this is a class pack. It has, like I said, it has TV remotes, Qti line followers, and turrets for the ping that comes with it. But it also has back here some rechargeable batteries and battery chargers. And that makes it really nice. Students at the end of the day can just put the batteries back in the chargers. They can charge overnight for the next session. So this is a good little kit. And I'll come back to this. Close tabs to the right. Okay, so those are the add-ons for the robots, but the activity board itself is very versatile. Here are a whole lot of applications that involve various peripherals that you can connect to the propeller activity board and program in Blockly. So let's, for example, take a look at tilt tones. Okay, so here is tilt tones. You don't know anything about tilt tones, do you, Stephanie? I'm ribbing her because I think she started that. The tilt tones application originated with Stephanie. I think this one has a little bit extra in terms of some lights indicating where you're tilting. This is a cute little tilt sensor where it just simply has a ball bearing inside it that will complete electrical connections as you roll it back and forth inside its little case. There's also a more sophisticated accelerometer, which we'll probably see somewhere in here. We've got an OLED display, e-paper, some fun. We've got, I like the, is this the one I'm thinking about? I hope so. Yes, this is my favorite guy right here for Halloween. The Taco Monster. So it's using the standard servo that makes the ping turret turn to make its little mouth open and shut. And this is placed over an ActivityBot, or no, it's an ActivityBot with some crawler legs, which I don't know that we carry anymore. Stephanie?
we do.
Oh, we do. Okay, pardon me. I wish I'd have put them in there then. We do have crawler legs. We can do a search real quick. Another Halloween one is here. So I guess these fall in the realm of animatronics. I don't want to watch that for too long. So this is a page with lots of additional things that the students can do, and they may even decide to incorporate something like this into their robot project as well. But just so you know, the propeller on the propeller activity board has a lot of different applications published for it that that you can go to this page, which is in the slideshow, but I'll go ahead and paste it into the chat as well. There you go. And surprise, Stephanie. So with all this fuel for student projects, Stephanie has been working on art for a while, and she has this really neat project that is, I think it's still hanging on the wall. I'm not sure. We just kind of moved stuff around a little bit. I didn't check if it was there today, but here is the True Colors project by Stephanie, which was, you know, some of the ideas for this came from working with all these different applications, both robotic and just with the board. And so here we have an art installation. Stephanie, would you like to talk about this? I guess I'm in trouble for putting poor Stephanie on the spot. We cannot hear you.
Yeah, she's not available right now, so
Oh,
you can describe it.
I'll go ahead and describe it. So as Stephanie is walking closer and closer to this piece of art, a laser ping, which is just the laser version of the ping that's in your robot, notices that an object has come into its 3-meter sensing range. And as Stephanie or any casual watcher moves a little bit closer to it, the standard servo, the one that is used in the class pack to turn the ping sensor back and forth on the robot, rotates the various pieces of art so that you can see the colors inside it. And then as you back away, it gradually rotates everything back until it's just a little kind of piece of wall art again. So there's really a lot of room for student projects, both robotic and otherwise. And what we like to do is we try to appeal to as many students as possible. So we have the speaker for music, we have art options, animatronic options, and of course, robotics. All right, so this is another reminder from Monday that we have lessons. I just included the links here for the Blockly prop and the C versions of the tutorials. If you want to purchase products, again, there's the link down here. Just www.parallax.com/product category, separated by a dash, /ActivityBot -360. And that'll take you to all things ActivityBot 360. I meant to assign this as homework on Wednesday, but forgot. So this is now due whenever. You should have received, if you don't already have an account at learn.parallax.com, you can, we sent you an account activation, and then Stephanie sent you a letter that resembles this, but this one is for the microbit, and she sent out a ActivityBot specific version of this. So check these 2 emails. Each of them have instructions for you to make sure that you're set up on learn.parallax.com so you can go there and log in. Why would you want to log into learn.parallax.com? The answer to that is teacher resources. And so we have teacher resources for all Parallax products, or all Parallax educational products, I should say, right here. What's a microcontroller? That's the electronics that we're doing the next workshop on. Cyberbot, ActivityBot, Propeller, Scribbler 3 for the younger folks, and so on and so forth. And yeah, so since you can see ActivityBot, yeah, we could follow that link and it'll take us to the ActivityBot Educator Resources page. So here we are. And for example, the A to G articulation agreement with California State University and University of California, we have it for the Bobot robot, the ActivityBot, the what's a microcontroller with the basic stamp, the Arduino robot. And so these are all the codes for that. We also have some open downloads, teaching strategy guides, scope and sequence, which is nice for, it kind of goes along with what I just did during the show and tell about the different parts, but it also breaks it out into, a suggested number of hours. And it also does it with and without the additional projects that come in the class pack. The Blockly Prop FAQ for schools is primarily something you can give to your IT before they install your the Blockly Prop launcher software. Then there's the standards matrix, which you can download for standards alignment. And it lists the most popular, or the most common and applicable standards for the ActivityBot. And you can go through here and potentially do standards alignments if you need to justify the purchase with a standard, with standards aligned. Now, we also have assessment material. For that, you have to log in. And I just took that off screen so I can log in separately. Bear with me. Great. I forgot my password. Bear with me just another minute. Okay, so unfortunately, I forgot the password that I usually use as a teacher. Basically, you will not see any of this web developer stuff up here. So that's for editing the site. But now that I'm logged in, we can go back to educators, select ActivityBot resources. And again, you won't see any of these page editing things. And now, instead of, see, this is what it looked like before. It's saying you have to be logged in. And I followed the logged in link and then logged in off screen. And now we have the educator downloads. And so you can download the assessment materials primarily. and you can download them one at a time, or let's see, we should have them all in a single zip. Yeah. So this is the full assessment. So this is all of the assessment materials. And so if I download that, it's going to appear in my downloads, and then we'll go ahead and unzip it, which would be extract all in Windows. And then after it's extracted, looking inside the folder, we have both PDF and RTF, which is a Microsoft Word compatible format for all of the assessment materials, and it's broken out by chapter. So if we look at the Whiskers Navigate by Touch assessment materials, let's see where that opened up. Here we go. And so it is primarily worksheets that you can grade. It's summative. And so it goes through the different concepts that were introduced in the Whiskers chapter and challenges students to answer questions about the circuit, the code, how it works, and then make sure to be careful, because the answer key is part of the same document. So if you're printing this out for the students, the RTF file, by the way, is handy for Microsoft Word or for opening with Google Docs, because that way you can also customize and expand this. This PDF one is, well, you can also do it through the PDF, but it's a little bit more work. And so just keep in mind that these are not to be shared with the students as they are. It would just be, say, printing this handout, for example, up through page 4 and not any further, because once you get to page 5, this is the answer key. And so this is the part we ask that you not share out with the students. And that is how your learn.parallax.com account works. For those of you who did not receive an email, that would be either because it landed in your spam folder or because you already have an account. And if that's the case, you may need to, if you don't remember your password, there's a password update on the login page. So if I log out and then try to log back in by going to Educators and then following the login link, there is the request a new password if you've forgotten yours, and then email us if the email is only going to your old district and you're at a new one now, or have a new email address. Okay. And with that, we are just about done. I left this empty. Does anybody want to demo their application? Trying to get back to, here we go.
Or maybe after we stop the recording, just in case they don't want to share the background and that kind of thing.
Yes, that makes sense. So yeah, because I basically heard crickets. The important thing though was that I kind of guided everybody through what was documented on the ultrasound on Wednesday, and the idea is to go through the homework and pick another circuit to see how the pattern of building the circuit, testing the circuit, the sensor, building the sensor circuit, testing the sensor circuit, and then incorporating the sensor circuit into an application that involves navigation to see how that step-by-step process works for the students. So if you have not already tried one of those, be it whiskers or light following or infrared navigation, definitely take the time to go through and do one of those chapters. If you're new to electricity and electronics, I recommend the whiskers because that's that's where we always start with the students as a first circuit, because it's a very tangible thing where you push the whisker against an electrical contact and you can see the change from 1 to 0 when you do that. And so that's an important one if you're going to try one. And then the ultrasound and the infrared are very popular for show and tell. For example, if you're meeting with the PTA or have a table out to garner some interest in your robotics program, for example, that would be a case where having the infrared or the ultrasound going would be kind of popular. And especially if you get the ping turret for rotating the ping, that makes it even more fun. Let's see here. Okay, so we looked at videos of each one of those. So that being the whiskers, the light following, and the infrared. And then we saw David's submission of the infrared. Very nice job, David. And so last but not least is our how to contact us at Parallax. We have an educator hotline that's open 8 to 5 Pacific time. So if you're in a class and you have quite a few students approaching you with a particular question or something doesn't seem to be working for you, definitely give us a call. You can also call on that hotline to place purchase orders and to ask questions about POs as well as about technical stuff. So either one of those can go to the educator hotline and or education@parallax.com. We also have a direct sales line, 624-8333 in area code 916. We have some discussion forums and a Facebook page. Those are all available. And the one that I should have added here, need to remember to do that, going to www.parallax.com. If you go to www.parallax.com and then scroll all the way down to the bottom, you will also see our Facebook, Twitter, YouTube, and Pinterest, etc. They're all down here. And so, for example, I'll go ahead and follow YouTube. And so this is another place where you can find lots of good stuff. If you look at all our videos, we also have some helpful playlists. That's the way we organize a lot of the educator workshops. But you can also just run through here. And let's say, for example, you wanted to see the previous electronics with the microbit. It's called What's a Microcontroller? So I went ahead and hit Command F to find on the page. Now let's do cybersecurity. And we can see now, after doing Command F, that there are 6 cybersecurity videos available. That's actually 2 workshops, each of which had 3 2-hour sessions. And so those are recorded on here. But we could also do What's a Microcontroller? And we got 6 hits for that. Here's one right now. I won't play it at the moment, but you can go ahead and watch any of these and even follow along at your own pace. You're always welcome to contact me directly if you're trying to follow along at your own pace and need some resources, but that they are all handled the same way, where we have a slideshow with links to all the resources. So, the hope is that you'd see me clicking a link and you'd be able to follow that same link in the slideshow. So that is Parallax's social media. And that concludes the everything I plan to tell you about. And so I guess I'd like to move on to a little bit of open discussion first, or we could just go offline and do some circuit troubleshooting if you'd prefer to do that. But thanks for coming, everyone. And I really hope this workshop was helpful and informative, and that the ActivityBot can potentially benefit your students in the classroom.
So I think everybody's kind of quiet and shy. So I think we end the recording.
Okay, sounds good. Thanks for coming, everyone.